All right, so we're gonna finish up chapter 9 today. I'm not gonna do chapter 10 today. I'll do 10.1 on Thursday. That's where I introduce hypothesis testing. We'll see how it works, what's going on, and we'll start talking about the project on Thursday. We don't have that many sections left in this book. We got 10.1, which we're doing on Thursday. We got 10.2 and 10.3. And then I think chapter 11 has, so we got 2 sections after spring break. Then we've got chapter 11 has 3 sections. So 5, chapter 12 has 2 sections, and chapter 13's got 1. We got 8 sections to do after the spring break and 6 weeks to do it. So it's going to slow down. But so we're slowing down today. So this is let's get some shit going on. Math 21. What are we doing? We're doing some statistics, and we're talking about what we talked about last week previously on 21. Well, that's better. We need to get 24 changed to 21 changed to 24. So I can start off with previously on 21, 24. All right, so we're doing chapter 9. 9.1 was on inferential statistics. And we were inferring or figuring out population proportion. Based on sample data. We had sigma was our mean. Sorry, sigma was x over n, which was our proportion. And our standard deviation was p times 1 minus p divided by n, and then take the square root.
I was doing some homework earlier, and I feel like my math lab had like a worse equation than that, or for the, it was like confused me. It was on chapter 9 when I went to view an example. It like had a bunch of crap on there. I'm like, what?
I don't know. If you know what it is when you get home, send me the question number and I'll look. Or even within the question, hit ask my instructor, and that way I can take a look.
I think it was like question either 4 or 7 or something.
We'll find out. In StatCrunch, what did we do? Get that open over here. I hear a voice, but I don't see anyone's mouth moving. Oh, was it? I'm like, what's going on? I'm getting confused. Oh, yeah.
One sample with summaries.
And then you either had with summary or with data. And your homework should have examples for each. We did examples for a couple of them in class. And what did you need for that? You needed to know X, the number of successes. You need to know N, the number in sample.
Jesus Christ, dude.
That's excessive.
That's not gnarly.
Jesus Christ, David, like, why
I
we
didn't
gotta
say David,
use,
it's a dude.
why we gotta use the Lord's name in vain?
Oh.
That's funny. Coming from an atheist, that's fucking fantastic. All right, and we were doing confidence intervals. Right now, when we get back from spring break, we will start doing the other ones. But confidence intervals, we had to click on the confidence interval tab. And we had to do our percentage. We had to put our percentage in there. And as a decimal. That's a reminder. That's a weird way of saying reminder. Like stretched out to what I was saying too long. That's a recap of what we did last week, yes.
So for like, the questions where it's asking us to find like the population proportion or whatever it is, if it doesn't give us the percent, do we automatically just put 90% in StatCrunch?
If it doesn't give you a confidence interval to go off of, use 95. This is our default setting.
Okay. So, I got like some wrong numbers. Okay, thank you.
Mhm. The reason why it's the default setting is that means we're 95% confident that they have the value contained, which means we're 5% not. And we wanted, we like things 5% or less. For some reason, that's a magic number in statistics. So that's the idea of why we make it the default. So that was population proportion. Today we're doing population mean. So when everyone's ready, I will begin 9.2. Better out than in. You know, I could hurt myself if I keep it contained.
That's actually true.
I know it's true. You wouldn't want me to hurt myself, would you?
And who's gonna teach us?
Right. So instead, I just release the gas valve every once in a while. Like the tea kettle, it has to let out the steam a little bit. Entertain myself to almost no end. So 9.2, estimating a population mean. Well, just like with proportion, we need a mean and a standard deviation. So the mean is equal to actually the sample mean. And the standard deviation is the standard deviation of the population divided by the square root of n. Those are the formulas. This and this, these can be obtained from the sample. Sample data. The standard deviation of the population cannot be obtained from data. And guess what? We generally don't know it. If we knew this value, We already knew the mean. And thus we wouldn't need to estimate jack shit. So there's an enigma here. We need something and don't have this information. So there's a story I'm going to tell you. I'll let everybody finish writing before I tell the story. It's a good story, I think. All right, so back in the 1900s, there's this guy, his name's Gossett, that's his last name, his name's Gossett. He's working for Guinness Brewery. He's making beer. And he's in charge of like making sure like it's all like the same like strength and shit like that. And he needs some of this information and he can't get it, we don't have it. There's no way of knowing the population's deviation for beer because you're making new batches all the time. There's no way of getting this. So what does he do? He starts doing sample after sample after sample after test. There's a shitload of tests and he comes up with his own idea, his own way of going, how can I do a workaround to this? So Guinness wouldn't let him publish it, not under his name. Like, you're not using our shit under your name. So instead of going by Gossett, it's called Students Tea Distribution. Why he chose the name student, but that's the pseudonym that he used, Students Tea Distribution. And what tea uses we're not gonna do anything with that shit. Never. That looks funny. That is S divided by N down there. S divided by square root N. It's an awkward looking equation. It really is. And since this is in chapter 9, that might have been what you saw.
I think so.
So more importantly, how do we use it? Here we don't need the standard of the population deviation anymore, so we can run with it. So what's going on with the T distribution? Properties of the T distribution. Because everything that we do and from now on, we want a distribution that looks normal. Normal distributions meaning we can do all the like empirical rule shit. We can use all the stuff that we've been working on, all the stuff we like. Well, the T distribution is symmetrical and bell-shaped. So it looks a lot like the normal distribution. And it's centered at the mean equals 0. What's crazy is T is different depending on the sample size. And we saw that in the formula, there was an N in it, that's the sample size. So the T was actually dependent on the N. Since it is symmetrical, the area to the left of 0 and area to the right are both 0.5. The tails approach 0 or the number line, but never touch it. This is true with the normal distribution as well. So how is it a little bit different than our normal distribution Z? Maybe I'll change colors to make it pop. Tails are longer for T on the T distribution than the Z, which is our normal distribution. What this ends up happening, a picture kind of. We have our normal distribution like that. It takes longer to get that value. Like that's our T. We've got the mean in the center for both. Right here is like 1 mu plus 1 deviation. The mu plus 1 deviation is further to the right on T. So like the deviations are further away from the mean. Than on C. The reason the only way they could have possibly known this is they picked something that they knew the exact population of. So they already knew all the answers. And then did all this shit and just looked at the graph and go, oh, it looks more like this. I wonder if that's what Gossett did. It's got to be what Gossett did. Means is the standard deviation where the height at one standard deviation mark is actually lower than on the t distribution. S is our sample deviation. So it's kind of like something like that. T has the S height. The good thing about it is as n increases, S, the standard deviation for the sample, gets approximately equal to sigma, population to standard deviation. Sound a little wet, didn't it?
Are you sure Alicia's not real?
But how would you know? Because you're like immune to this.
No, you're never immune to your own farts. That's the one odor your body emits that you're not immune to. You will, if you don't take a shower for long enough, you will eventually smell yourself. That's not the case with farts. It's right away. If it's a bad fart, it's you know, like bitter beer face. You just,
You have Chinese food for lunch?
no,
No.
Did you have beans?
no,
Broccoli.
no. I don't know what I had. What did I have? I had an apple at 4:03, I had an apple at 1, and I had an egg sandwich with bacon in it for breakfast.
Delicious.
Egg.
Is it egg?
Yeah.
Eggs make you gassy?
Well, it depends.
Eggs, yeah.
Like an egg sandwich or just like.
Like
bacon
fried egg sandwich.
Yeah.
That's a bad beat for y'all because I have that generally every day.
Oh, shit.
Every once in a while, I'll change it up with like oatmeal. All right. So let's go on. Let's get that's the boring shit that you need to like. Why does T work? That's why T's works. So because it does, as n gets larger, it effectively starts looking like the normal distribution. So in fact, if n is greater than or equal to 30, it's approximately bell-shaped, and we can use the normal distribution. It's normally distributed. Like, remember, we had some criteria to check for population or proportion. We had to do that n times p times 1 minus p was greater than or equal to 10. We have some tests here. Either n is greater than 30 and we're good, we're set. If n is less than 30, we have some stuff to check. Want to look at a QQ plot? Which was something we'll do more of, but I'm pretty sure we looked at it in chapter 4. It needs to look approximately linear. Or it needs to look like a straight line. We want to check the correlation coefficient. This was definitely in chapter 4. And compare it to the critical value. CV. The correlation coefficient goes by R. And we want R to be greater than CV. They're just numbers up from a table. R you get from the computer. CV is from a table. Generally, if QQ plot looks like a line, you're generally pretty good. The other thing you want is the box plot can't have any outliers. Those are like the requirements we have. If we don't meet them, using the normal distribution may not be accurate. No guarantees on our distribution. The easiest one to fix here is do more samples. Get more data points in your sample. When you get n over 30, it's a done deal. Stack crunch commands. Stats. T-stats. At this point, we have 3 options. We have 1 sample. We have 2 sample. And we have paired. Usually we're just doing the first one for confidence intervals. When we do hypothesis tests, the 1 sample will be chapter 11. The 2 sample and paired are chapter 12. If we need to calculate T, stats, calculators, T. And at least one thing you'll need for that, it will say DF, it's the degrees of freedom. And it equals n minus 1. So your sample size minus 1. Now we'll do a couple examples from the homework. By couple, I mean 4. It's not really a couple. That's not even a few, that's many. We're going to do many examples from the homework. Just to make sure we're all good. The ones I'm gonna be doing are 11, 15, 16, 17. So from the homework,
What about like,
There you go.
because I was doing some of the homework and I was having to understand some of it, but when I got towards the end, I.
well, maybe that's because it was based on shit that we're doing today. Because guess what? Numbers that are higher in this sequence of homework
Yeah,
tend to be related to the sections that are later. And since 9.1 was done first and we're doing 9.2 now, I'm betting that's in the section we're in right now. You
Yeah.
might see one just like it.
so can we get an example of those?
I'll look at it and see if we need to. I already said we're gonna do fucking 4 examples. After that, I'll glance at 25 and say, do you still need help?
Okay,
But I bet we go over the steps in one of the other problems. All right. Number 11. Nope, I found out long ago that's not the best way to do this. Because I'm going to have, I'm going to open up, I already got StackCrunch over there. What are we doing? Where'd it go? It went away. That's fucking rude. Why'd it go away? I do it right here. There we go. That's what I want. So it says a researcher wishes to estimate the proportion of adults who have high-speed internet access. What size sample should be obtained if she wishes the estimate to be within 0.01 with 95% confidence if the previous estimate is 0.38 and she didn't use prior estimates. So this is actually, I should have done this one last week. So problem number 11 wants us to find the sample size. This is where some of the other options for under proportion stats come in handy. We're still going to do one sample. And now we're going to choose power width sample size. Let me look at it real quick and see what I need to label real quick. It will ask you for 4 things. Well, it's got boxes for 4 things. It's got a box for confidence level. It has a box. It has a box for target proportion. It has a box for the width. And it has a box for sample size. We are going to fill in the first 3. So here, whatever our confidence level is, if it's 95%, we would put in 0.95. Kind of like we're doing the confidence interval thing. The width is 2 times the error. And so the error is generally, they'll say something like, we want it within so-and-so. In this case, 0.1 is what it said. Nope, it said 0.01. That's my E. So when I go to put it in my width, I'm going to double it. Target proportion is either given to you. If not, use 0.5. In this case, they said the previous estimate was 0.38. It actually does an A and a B. It says 0.38 and it says no prior estimate. So when I do B, I'm going to 0.5. Once you have those, you hit compute and it will fill in this box for you. Okay? Note to self, just write it in there right now. Do number 11 in this section. And then you need to do number 11 over here. All right. Everybody ready to hop over and look at it? So I went stats, proportion stats, one sample, power sample size. You want to click on confidence interval width up here. So click on confidence interval width. You'll notice if you don't have the same boxes I had written down. If you have boxes like this, you're not on the right screen yet.
This is what I tried putting in earlier and like I didn't press on the top of it.
That's good. I knew I had it in here somewhere. All right, so my problem said use an estimate within 0.01. So within 0.01 means my width is 0.02. My confidence estimate or interval is 95%. I've got that. Notice the target proportion starts off at 0.5. That's like the default. That's really like a worst case scenario. Generally, it's the one that has like, it makes you require the biggest sample size. This said use 0.38 though. So I'm going to put that in and it tells me 9051. It even rounded for me. It rounded for me by changing the width to be what it wanted. Oh, that's not, I need to click check answer there. And then it says do part B where I don't use any prior estimates. Oh, neat. You can click on this and that's fucking cool. Never done that before. Click on the graph and see what each thing's required. I'm going to change the width back to 0.02 and change my target proportion to 0.5 for no prior estimates. Here it says 9,604. That's all that problem had. Simple enough, right? When you know what to do. I didn't really have to compute anything other than double my error. It said within 0.01 and I needed to put in 0.02. But other than that, everything was given to me. All right, let's take a look at 15. Does an agricultural researcher is interested in estimating the mean length of the growing season in a region. Treating the last 10 years as a simple random sample, he obtains the following data, which represent the number of days of the growing season. What is the point estimate of the population mean number of days of the growing season? So, everyone with me? Oh, wait, there it is. That's what I want right there. I'm going to open this in StatCrunch. That way I don't fuck up any numbers that are already done for me. The point estimate should just be the mean, but I'm going to go through and take a look at stats, T-stats, one sample. I actually have data here, so I'm going to say with data. Tells me variable 1, I'll say 0.95. Let's see what happens. It tells me my sample mean is 164.6 and standard error is 5.477. We could also have done summary stats columns. If I do summary stats in columns with mean and standard deviation. Oh, that's. Oh, yeah, it's samples. What's off here? Why is that so large? That number looks like. Well, the 164, oh, yeah, it's unrelated because the standard deviations are not the same. Sample mean is 164.6, 164.6. That's what they wanted right here. That's my point estimate. Oh, that was easy. All I wanted us to do for that was find the mean. Number 16. In a survey conducted by the Gallup organization, 1,100 adult Americans were asked how many hours they worked in the previous week. Based on the results, a 95% confidence interval for the mean number of hours worked has a lower bound of 42.7 and an upper bound of 44.5. Provide 2 recommendations for decreasing the margin of error of the interval. I'm going to draw a picture of this. So they told me I had 95%. This was problem number 16. 95%. The lower bound was 42.7. The upper bound was 44.5. And my mean should be right in the middle. And this was based on 95%. If I want to be more confident, if I'm more confident, like say 99%, I need to make this bigger to get 99%. If I went for less confident, say 90%. I have to make this window smaller. Okay, and what else is going on here? We had T equaled X bar minus mu over S divided by square root N. So we're still dividing by N. Let's see. The bigger we make the sample size, the smaller that window should be, the more accurate it should be. Is that true? Yeah. I'm pretty sure as N increases. Yeah, our standard deviations go down. As N increases, the standard deviation goes down. Or approaches the population deviation. Which means it makes it narrower on that graph. Those are the things we want. It said, make it go smaller. Smaller is, I need less confident. And I need N to increase, because that'll make it narrower as well. You won't be tested on that, but it is on the homework, so I thought I'd better show you that. God, I hope that last one's correct. Or I'm gonna look like an idiot in a second. Let's go see if I look like an idiot. I said we wanted to be less confident. So decrease the confidence level. And I said increase the sample size. There you go. Okay, not looking like an idiot. My reasoning was sound, but most people, that's like, I've been doing this a while and I still had to stop and really think about it. So I don't know that this is a good question for students. Maybe I should take it out of future sections. Let's take a look at question 17. It says a simple random sample of size N is drawn from a population that is normally distributed. The sample mean X bar is found to be 113. And the sample standard deviation S is found to be 8. Construct a 99% confidence interval about the mean if the sample size is for A is 27. On B, they change it to 19. And on C, they put it back up to 27, but change the confidence interval to 96. So it looks like I'm going to be doing some more pictures for this shit. Because they're going to want us to compare it. So let's just get the data they want first. Where is my cursor? And I go stats, T-stats, one sample with summary. It wants the sample mean, standard deviation, and size. They gave us those. 113, 8. And for part A, it's 27. And I'm going to do a 99% confidence interval. Click compute. So it gives me these lower limits and it wants it to 1 decimal place. I'm going to write this information down because I know I'm going to need it in a second. Then it says construct a confidence interval where I still have 99% and n is 19. I can either do options and edit and just change the value here. Or I could make a new one. Stats, T-stats, 1 sample with summary. Putting in all the same numbers again. Except sample size is now 19. And for this one, they give me 107.7. Where did that 8 come from? Oops. And upper bound is 118.3. And I'll click check answer. And now I ask, how does decreasing the sample size affect the margin of error? Let's take a look at that on the camera. So I have 113 in the middle. And here is like 108. 107 there. Up here, I'll put 117 and 118. The 99% with n equals 27 went from 108.7 to 117 point. I did not scale this picture very well, did I? This should be more centered. So that's my n equals 27 range. My n equals 19 range goes from 107.7 to 118.3. So the question is, oh, static shock. What happened as I decreased n? It got bigger, which means there's more error. Error is based from the center outward. That's error, and that's error range. And so as we dropped down, as n went down, the error got bigger. But it kind of helps to look at it on a little number line and see what it looked like. Oh, wait, shit, some of you are still writing. Let me put it back.
Oh,
Other people are still writing. Is it? You Chubby?
Yeah.
All right, so we had, as the sample size decreases, the margin of error increases. That's what we found when I drew the picture. Now they're gonna have us do it where it's 96% and n equals 27. So rather than going and changing or redoing the thing, edit is often helpful when you're doing stuff. It speeds it up. I don't need to re-enter anything up here. Well, I need to change that to 27. But now it wants that as a confidence interval of 96. So edit allows you to change the stuff. Once you've written down what you need, you don't need that thing up anymore. And it can save you some time entering stuff. And now I've got 109.7 is my lower value. And my upper value is 116.3. I'll write those down too. Because I'm sure they're gonna ask me more shit about this. It says compare the results to those in part A. That's where we had 99% and 27. How does decreasing the level of confidence affect the size of the margin of error? So we're doing the same thing. We need to see if it makes it wider or narrower. So I'm going to come over and look at what that stuff gave me. Maybe I'll redraw it. The n equals 20, or the 99% was going from like here to here. That was the part A value. Part C value is going from 109.7, which is higher than 108.7. And 116.3 is below 117. So this was my thing for part C. So again, the error is half this distance. That's E, that's E. It got smaller. So as my confidence level went down, my margin of error went down. What? Yeah, as confidence went down, so did the margin of error. You guys ready to go look at it? This confidence went down, margin went down. Okay. That's the one we're looking for. As the level of confidence decreases, we need the size of the interval to decrease. Should the confidence intervals in parts A and C have been computed if the population had not been normally distributed? We had each sample size we did was less than 30. So no. The net population needs to be normally distributed because the sample size is not large enough. Oh, it's not what I wanted. There we go. Population needs to be normally distributed because each sample size is less than 30. That's kind of what doing the QQ plot and stuff shows. That's it on that one. 25. I bet you could do this now. You think? It says find a confidence interval that's 90%. They gave us N. They gave us the sample mean and they gave us the standard deviation. You're going to come over here and you're going to go stats, T-stats, one sample with summary again. And you're just going to enter what they said. The mean is 55. The standard deviation is 15. Sample size is 19. And confidence level is 90. And you're going to enter the lower limit and the upper limit. That's it. That's all that's in chapter 9. Questions? You were free to go.
You said it wrong. You will be DTFO.
She, get the fuck out. I said that in the last class. I said GTFO. Go on, get. Go on, get. What? You could stay here and work on your homework if you like.
I'm signing my life away in math lab. Like in the last few weeks. When I go home.
You're almost done,
Taco truck, I know.
right? It is Taco Tuesday. I need some tacos. Is there any good taco truck that's having a special for Taco Tuesday? The one I used to go to doesn't do it anymore.
There's a place on in my style movie for, you have for like $1.25. I mean, it's not really a difference.
You live in Visalia?
No, I live in Claire.
Taco San Marcos is hecka good.
Oh, yeah.
I do like Taco San Marcos. Yeah, those are
You
pretty
can
good.
online for the cheap, just go pick it up.
Yeah.
No, Taco Perez.
Yeah, it's in the parking lot, like a little Mexican meat market.
Let me stop recording. I'll look it up real quick.
I'll show you.